Welcome to qnawire.
All right, so problem number 31 states that an electron is moving past the square barrier shown in figure 40.19, but the energy of the electron is greater than the barrier height. If E is equal to 2u0, what is the ratio of the de Broglie wavelength of the electron in the region x is greater than L to the wavelength for the region 0 is less than x, which is less than L? All right, so figure 40.19 gives a square barrier like this. Let me give myself some more room here. All right, where this is 0, this is L, this is the x-axis. This is u of x. And this is u0. Okay, so the electron energy is at 2 u0. All right, so now what we need to solve this problem to start with is we need to know what the de Broglie wavelength is. So the de Broglie wavelength is equal over the momentum of the electron, where K, which is the kinetic energy of the electron, is equal to p squared over 2m, which is the momentum squared, and the total energy is equal to the kinetic energy plus the potential energy. So now if you solve for p here, plug it in here, you get lambda is equal to h over the square root of 2mk. All right, so one thing if you notice here, h and m are both constants. So if we solve for lambda k, lambda times the square root of k is equal to h over the square root of 2m. So no matter where you're at in this region, this will always be the same. So what we can say is that lambda 1 square root of k1 is equal to lambda 2 square root of k2, where lambda 1 and k1 are for x is greater than L, where k1 is equal to 2, and then lambda 2 and k2 are for 0 is less than x, which is less than L, where k2 is going to be equal to the kinetic energy minus the potential energy. K minus u. Now, which is equal to E minus u naught, which is just equal to u naught, because E is equal to 2u naught. All right, so now we take the ratio, lambda 1 over lambda 2 is just equal to the square root of k2 over the square root of k1, which is equal to the square root of k2, which is u0, divided by the square root of k1, which is 2u0, which is just equal to 1 over the square root of 2. So that is the ratio of the de Broglie wavelength in the region, there we go, in the region here to the ratio in the region here.